A tree that once fed a nation vanished in a single human lifetime. In parts of the Appalachian forest, people said 1 in every 4 hardwood trees was American chestnut. Then, in about 40 years, it was killed by a fungus. Now we might bring it back. But the comeback has become a fight. Breeders versus biotech, non-profits versus regulators, neighbors versus neighbors. Because the hardest question is not, can we revive the chestnut? It is who gets to decide what revived even means. Before the blight, there were close to 4 billion American chestnut trees across the eastern United States. They grew fast and tall, the redwood of the East. Their nuts fed wildlife and families. Their straight, rot-resistant wood became fence posts, barns, and railroad ties. Chestnut was not just a tree, it was food, shelter, and cash. In the early 1900s, Asian chestnut trees were imported for planting and breeding. They carried a fungus they could tolerate. The American chestnut could not. In the year 1904, a forester found sick chestnuts at the New York Zoological Park, the Bronx Zoo. That was the start of chestnut blight in North America. By around 1940, most mature American chestnuts had been girdled and killed. So here is the tension. If we can bring the chestnut back, which chestnut do we bring back? And who has the authority to release it into living forests? Chestnut blight is ruthless. The fungus slips into cracks in bark. It grows under the surface. It forms a canker that wraps around the trunk like a belt. Once the tree is girdled, the flow of water and sugars stops. The top dies, then the whole tree follows. The tragedy is that the tree did not truly go extinct. Its roots often survive. Old stumps send up new shoots. But when those shoots get bigger, the blight returns. They die back, and the root tries again. For a century, the American chestnut has lived as a repeating sprout, unable to become a full forest giant. Estimates say the blight killed roughly 3.5 to 4 billion trees in less than 50 years. That is not a normal change. That is a collapse. Oaks and maples moved in, people adapted. But the chestnut's role, heavy nuts and durable wood, never had a perfect replacement. So when people talk about restoration, they are talking about changing the future forest. And that is where the arguments start. For decades, the most hopeful plan sounded old-fashioned. Traditional breeding. The idea was to borrow blight resistance from Chinese chestnut. Then you backcross those hybrids again and again with the American chestnut. You try to keep the resistance, but recover the American tree's shape and growth. In the 1980s, a plant breeder named Charles Burnham argued this method could work. In 1983, the American Chestnut Foundation formed to test and scale that plan. It became a huge volunteer effort. Orchards were planted, flowers were hand-pollinated, family lines were tracked like a living library. This is the part that feels like a classic comeback, but trees move on tree time. Each generation takes years. Blight resistance turned out to be complex, not a single switch. Some backcross lines looked strong in one test, then weaker in another. Over time, people began to ask a quiet question. What if the slow path never gets us all the way there? Then a second path arrived, and it sounded like a shortcut. Biotechnology. Instead of moving resistance through crossing, you add a protective gene. Researchers at the State University of New York College of Environmental Science and Forestry developed a line called Darling. It carries a gene from wheat that makes an enzyme called oxalate oxidase. The blight fungus uses oxalic acid like a weapon. Oxalate oxidase breaks down that acid. So the tree does not need perfect resistance. It needs a shield that blunts the fungus's main attack. One small change, a big effect. A tree that looks American but might survive. And the researchers talked about restoration, not profit. They filed petitions to begin federal review so the tree could someday move beyond research plots. But the moment you say release, the story stops being only science. It becomes law, trust, and consent. In the United States, releasing a genetically engineered organism involves federal review and public comment. For the Darling line, the review ran through the United States Department of Agriculture's Animal and Plant Health Inspection Service, often called APHIS. There were draft assessments and thick documents, and suddenly, a tree became a national argument. Environmental groups raised worries about irreversible spread. Foresters asked practical questions about scale and diversity. Indigenous communities raised a deeper concern. A tree does not stay inside a fence. Pollen moves, seeds move. So a decision made in one place can affect another place that never agreed. Here is where the story turns hard. People who wanted the same goal, a restored chestnut, began to fight over the method. Some said, do not release any genetically engineered tree into wild ecosystems. Once it spreads, you cannot call it back. Others said we already changed these forests through trade and disease. Refusing a tool because it feels strange will not bring the chestnut back. Then, in December of 2023, the conflict exploded. The American Chestnut Foundation said it would discontinue its development of Darling 58. It cited significant performance limitations. That one phrase landed like a stone because it suggested the most famous biotech chestnut might not be suitable as a restoration tree. And it raised a new question. If even the biggest partners cannot agree, who decides what counts as good enough for release? And this is the moment when it gets worse, because forests do not care about press releases. A restoration tree has to work in messy conditions, different soils, different microclimates, different fungal strains, and decades of stress. If a blight-tolerant line performs unevenly, the risk is not only failure, the risk is backlash. One bad rollout could turn the whole public against restoration and set the project back another generation. After the December announcement, the debate shifted from whether biotech is allowed to which biotech and what proof is required. Some supporters asked for more transparent field data. Some critics said the episode showed why engineered trees should never leave research plots. Others said the opposite. They argued this is exactly how science should work. You test, you find limits, you adjust, and you keep going. But notice what changed. The chestnut was no longer just a victim of a fungus. It became a test of who we trust when the data gets complicated. And that brings us back to the title question. Who decides how the American chestnut comes back? In practice, it is a network. Researchers design lines and run trials. Non-profits raise money and recruit planters. Federal agencies review risk and write decisions into law. State agencies decide what happens on public land. Private landowners decide what happens on private land. Communities, including tribes, decide what feels acceptable on their homelands. No single vote settles it. It is a slow negotiation held together by trust. Now the comeback splits into two big stories. One story says restoration should be built by breeding, step by step, with many lines and local diversity. The other story says restoration may require modern tools because the blight arrived through modern trade, and both stories have a fear behind them. Breeders fear a rushed release that damages ecosystems and public trust. Biotech supporters fear endless delay that becomes a slow surrender. Even if you had a blight-tolerant tree tomorrow, restoration is not one planting. A single best tree is not a forest. You need many families. You need trees that can handle drought, heat, insects, and new diseases. That is why some foresters argue no single approach is enough. Breeding can build diversity. Biotech can add a shield. Future gene editing might change only the chestnut's own DNA. In the real world, the forest may demand all of it. There is also a surprising twist from overseas. In Europe, chestnut blight is often less deadly, in part because a virus can infect the blight fungus and weaken it. This is called hypovirulence. It shows biology can change the rules over time, but it also warns us. A fix that looks strong in one place can fail in another. A tree that survives blight still has to survive everything else. So when you hear "bring back the American chestnut," listen for the fine print. Is it a backcross chestnut, mostly American by breeding? Is it a transgenic chestnut with a wheat gene, or is it a future tree made by gene editing? Each option carries a different idea of restoration, and each points to a different group of people who get to decide. Here is the honest ending. No single person decides. Not a lab, not a non-profit, not a federal agency. Approval is not the same as legitimacy. In practice, the comeback will be decided by a patchwork of choices. Federal agencies can approve a path. States can shape it. Landowners can accept or refuse plantings, and communities can support or resist. One forest at a time, the decision will be made again and again. A century ago, a few infected trees at the Bronx Zoo marked the start of a disaster. In less than 50 years, billions of chestnuts were gone. Now, we are trying to reverse that story. But restoration is not only biology, it is trust, governance, and humility. And there is one last detail that makes this story feel personal. American chestnut still lives underground in roots that refuse to die. Across the east, chestnut sprouts still rise from old stumps. They are waiting for a future where they can grow past the blight line. The science may help, but the final question is still the one we started with. Who decides what counts as bringing a species back? If you found this fascinating, hit subscribe for more stories like this. The next restoration debate is already beginning, and it may involve the trees outside your own window.